we're going to go over slopes and angles of lines in the Cartesian plane. Okay, so let's draw our axes for the Cartesian plane. X-axis and y-axis. And if we have a line and if we know 2 points on the line, say these 2 points here, then we can find the slope of this line. And remember, the slope, by slope we mean the rise over the run. Okay, so let's say that this point right here is 2, 1. These might not be in scale. This one, let's say that it's 5, 2. And let's see what the slope of this line would be if those are the points. So you can always construct a right triangle like this. And the rise, which is this part, is basically 2 minus 1, right? It's the difference in the y values. That's 2 minus 1. The run here is the difference in the x values, 5 minus 2. So for the slope, we have rise, which is 2 minus 1, which is 1, over the run, which is 5 minus 2, or 3. So the slope for this line equals 1/3. And this means that every time it goes 1 to the right, or sorry, every time it goes up 1, it's rise over run, every time it goes up 1, it goes 3 places to the right. Okay, that's what the slope of 1/3 means. Okay, this is not too hard. I'm hoping this is all review. So the formula, if you are to put a formula for finding the slope, would be y2 minus y1. This is how it's commonly written, over x2 minus x1. It looks a bit complicated, but really this means the difference in the x values, or the difference in the y values divided by the difference in the x values. And the reason they have 1 and 2 labeled here is to differentiate this y value, for example. I'll use a different color so that's easier to see. This y value from this y value, and this x value from this x value. So it doesn't really matter even if you switch the 1s and the 2s here, except if you switch the 1 and the 2 in the numerator, you also have to switch them in the denominator. You have to make sure that the numbers match like this vertically. So you have to make sure that you're subtracting the same point. I don't know how to put this in words, but basically if you've subtracted this value from this value, then you have to subtract the corresponding x value from this value. You can't do y2 minus y1 and then suddenly do x1 minus x2 in the denominator. Okay, so that's the slope. And what about the angle? What do we mean by the angle? So if we have, let me redraw this axis here. So if we have a line, let me actually draw it so that it goes right through the origin. Okay, the angle, let's first look at the angle of inclination. Angle of inclination. And this basically means what angle does it make with the x-axis? It's talking about this angle right here. And it doesn't really have to pass through the origin. It can pass like this. The line can pass like that, and then you'll be finding this angle right here. But the way you find that angle is the same. Now this you might have not done as often as you've done slopes in algebra, but it's again not that hard to find what that angle would be. So basically you can just pick a point on this line, on this green line here. So let's say that, let's try a different color here. Let's say that that point right there is 1, 2. Okay, then if you can construct from that point to the x-axis and to this line, you can construct a right triangle like this. And for this right triangle, this length right here would be 2. This length right here would be 1. And since it's a right triangle, you can use the trigonometric functions to find what this angle would be right here. So since we know the opposite side and the adjacent side of this angle, we can use the tangent function. So in other words, tangent of that angle is going to equal opposite over the adjacent. Opposite over the adjacent, 2 over 1. And to find the angle, we can just use the inverse arctan. Angle is going to be arctan of 2 over 1. Okay, but to generalize this situation, notice that 2 over 1 right here, that is rise over run. Rise was 2, run was 1. So in fact, this value right here is the slope of the line. That's the rise over the run. So with the general formula for the inclination angle would be, you'll be finding the arctan of the slope, x2 minus x1. And notice to find the slope or the inclination of a line, you need to know 2 points, at least 2 points. For this green line, we knew that this point right here was 0, 0. So that's how we knew that the slope was 2 over 1. You can't really find these if you only know 1 point of the line. Okay, so that's how you find the inclination angle of that line using this formula right here. And lastly, I would like to cover finding the angle made by 2 lines on the coordinate plane. So this time, we're not looking at the angle that it makes with the x-axis, but we're looking at 2 lines, and we're looking at the angle that those 2 lines make with each other. So let's have one angle like this, or one line like that, another line like this. They intersect right here. And we want to find this angle right here. What would that angle equal? Well, you can move this angle. You can move this angle right here down so that this point is on the x-axis. And the reason we're doing that, this is not going to change the angle. The angle is going to stay the same. Right? We're trying to find this angle right here, right? So this angle will stay the same. Oh, the red line doesn't look. The red line, this red line should be parallel to this red line. It doesn't look like that in the picture, but okay, let me try it so that it looks similar. Okay, so these angles, the yellow angles here should be the same. And if you look at this angle, well, that is just the difference between the inclination angle of the red line, that angle right there, minus the inclination angle of the blue line, minus this angle. Right? So the purple angle minus the orange angle will equal the yellow angle. So to find the angle between the 2 lines, you can just find the inclination angle of the two lines and take the difference. So this would be the angle between two lines. Okay, in which case you can just find the difference of the inclination angle of the two lines. And the reason I'm just writing this out instead of writing a formula is I think it's much easier to memorize the concept, because once I start writing this out as a formula, it's going to look very complicated. But if you understand the concept, it's actually not that hard. You're just finding the bigger angle, I guess, the angle of inclination that is bigger, and then subtract the smaller angle of inclination from that to get the angle in between. Okay, so that's how you can find the angle between those two lines.